My name is John Boktor. I'm with PCL Construction, leading kind of the innovation and technology efforts. We call them client relationships, but I do anything that enhances our work in terms of technology at a global or corporate level, as well as the R&D side of things. So I've delved into robotics, delved into, as what we're doing right now, AI, some things a little bit on the BIM side, but mainly IoT sensors and whatnot. That's why I'm speaking to that topic today. Also, been in the industry for about 17 years, mainly in the field side actually, and then veered into this technology world after a little bit of my stint in the US with another company. So I also lead a lot of our efforts when it comes to vendor partnerships, or what we call kind of being strategic partners. This is not exclusive, but it's partnerships with companies like Eddy Solutions and Coppertree and Lighting Technologies and others that enhance our operational side of the business. So the key is to figure out how we can partner with different entities to really gain and enhance productivity on our project sites. So I'll turn it over to Adam to introduce himself here.
Yeah, hey guys, found a mic. So my name's Adam Bartman with Eddy Solutions. A bit about my background. So I started in the plumbing industry when I was like 17, owned and operated a high-rise plumbing service company that naturally led into leak detection. So we started a company, raised some money, started a hardware software platform. Long story short, about 4.5 years ago I was acquired by Eddy. So I'm acting now as their COO. Really responsible for the teams that do a lot of our design and development of solutions for buildings, then follow up with the project teams that help with the actual implementation of that technology. And then the third department, let's call it, that supports the active monitoring services that come after. And we'll touch on some of those very briefly about Eddy. So the company's about 11 years old now. We work primarily across Canada, but over the last, let's say, 2 years, we've started to push into the US. Clients like the usual developers across Canada, Tridel, Daniels, Greenpark, etc. Also some really great institutions out in the US, mainly thanks to the partnership with PCL. So we've done a lot of work with UCLA, Four Seasons, and some of those, just to get a sense of the type of clients that we work for. So yeah, that's a bit about me.
Thanks, Adam. So to get us started, just a very high-level kind of agenda. This is more of a technical base, or call it a bit of a technical based presentation today, as it is a case study, but I think it will be very informative. It's one of our favorite ones to do because it has good substantial ROI. And we like to talk about that from a case study perspective. So we'll go through a quick project overview. We'll talk about IoT deployment strategy when it came to Wawanesa Tower, kind of what the water mitigation IoT system perspective looked like, and then we'll get into real detail, and Adam will walk through, and myself, into kind of sequencing or phasing of how we deployed the water mitigation system through Eddy Solutions, and then talk about a bit of the ROI at the end of the presentation of what it means to really plan and pre-plan and to institute proper organized plan at the beginning to ensure that you have a successful deployment of technology when it comes to IoT deployment. So, Wawanesa Tower, sure, okay, good. So it's a $190 million base building and fit out phase, so that's about the close to the project value. So we started the base building, then we got a change order for the fit out for Wawanesa Insurance, hence the Wawanesa Tower. And project schedule is about 24 months with a year of pre-con beforehand, and that's important because we also were in that phase to do a lot of that IoT deployment planning. So it's a construction of a new 23-story office tower in the downtown Winnipeg area with one level of underground parking, cast-in-place concrete. The project included the superstructure, so the entire structure already in the base building work for the interior fit out afterwards for the Wawanesa Insurance, and the developer is True North. So True North was the main developer on the project, and PCL has been working with True North for a while now, for a long time. So that's a bit about the project. In terms of the Internet of Things or IoT sensor monitoring deployment strategy, it really comes down to really one main perspective, and the insurance folks in the room. Just quickly, how many people are kind of the GC side here? Sorry. Okay. And then vendor or technology partners? Okay, insurance, yeah. Developers or clients or, no, then I think institution, right? Institutional, yeah. Anybody from institution as well? Thanks, Gary. Okay. It really comes down to understanding risk on your project, and we'll define what that looks like in a minute here, and then intentionally pre-planning or planning for that risk. So it's no longer, as we've learned and we've experienced in PCL, it's no longer just hey, put your IoT sensors anywhere you want, and because it's cool technology, or hey, yes, I have some things that I want to look at because technology, because IoT is the thing to do. But it starts with the risk, and then from risk, you really want to intentionally pre-plan or plan even way ahead of time to really be successful in a full-scale deployment. And that's the key here in the case study. It's not just something small, but a really large-scale deployment. This was pretty new to us. Just to give everybody perspective, it was about 2.5, 3 years ago. We took upon it for the pre-planning phase. It was about 6 months prior to start the project. We collaborated between the estimator, so the estimator of the project, superintendent, project manager, and then a few of the subcontractors, mainly mechanical, electrical subcontractor. The client portion of this came later, and we're going to allude to this a little bit later. There was a real intention to put layout drawings. We were experimenting with IoT sensors over a couple of years back before that too as well, but this time we wanted to really hone in on putting it as part of the design, if not just, they were part of the drawings, but also part of the design intent. So it is for sensors, so IoT sensors across the board, and then gateway communication hub placements. And for those who don't know what a gateway or a communication hub is, it's got to be a router that routes that IoT signal. So the IoT device that you have, that sensor, that signal goes back to the hub. That hub then brings it out to the cloud, and then we see it on some sort of dashboard or interface. But that's a really critical item. I call it kind of the brain power of any IoT sensor deployment. Sensors included in this particular project, and we've really evolved since then, but at the time what we really were comfortable to do was temperature and humidity control, and then water leak detection control at a sensor level, and then we'll talk about how that led into a permanent water mitigation system. From there, we determine areas and specific spaces when it comes to risk mitigation. So, as I mentioned earlier, risk was how we approached it, and how we mitigated that risk is through the IoT sensor part. So, first part of this was looking at our temp heating plan. So we had a temp heating plan. How do we tie the IoT sensors to it? So we had to maintain, of course, not just during the winter because it is cold in Winnipeg, as a lot of you know.
Yeah, we were out there. There was one day it was -40 and the elevator shut down, so it was pretty excessive.
And that happens a lot of Winnipeg. So, but in the case of from a design perspective, we were obligated to maintain 17 degrees Celsius in the floor spaces to comply with manufacturer requirements in terms of drywall, finishes, flooring, and adhesive in terms of flooring. And then in that case, if we didn't maintain that, you can imagine kind of the warranty issues that come with that. So that was kind of the first part, to ensure that we had met those requirements from where we started that work. And of course that work started early, so we had still our heaters in place during that time. We needed to maintain a relative humidity across the building as well, between 5 and 12% across the board. And if not, we would have to either, in some cases, humidify or dehumidify the spaces, and so then you're bringing much more equipment into the built environment. Mechanical rooms and electrical rooms and data rooms and server rooms were a very particular issue in terms of risk as well. We had to really pay a lot of attention in terms of the cooling requirements. As you can imagine, as we all know, once you get equipment in and commissioned and online, you need that heating perspective, especially in terms of electrical rooms. We have transformers or servers in terms of data rooms, starts getting up there. And so controlling that in the cooling side is very, very important. And as a lot of GCs will go through this, sometimes when you're doing commissioning cooling, even beforehand, before you get into that permanent stage, things go down, and you have to understand when you don't have cooling in the space, or your equipment will suffer, and then you're looking at long lead times and whatnot. Our mechanical panel specifically on this project was a bit of a more high risk. We didn't want to make sure that we didn't have freezing temperatures before the permanent systems were in place, and because Winnipeg is cold, so that was a real risk. The last part, which led to the water mitigation system plan that we weren't really expecting at the beginning of our pre-planning stage, we We particularly looked at the 10 bathrooms to make sure that there's IoT leak detection sensors. However, this started the conversation now with the client. When we presented our IoT deployment plan, the client then started getting interested into what a full water mitigation system plan looked like. And the reason is True North experience with PCL. So PCL had a lot of experience with this and True North as well. The two towers, and you'll see this in the testimony, the two towers, I think there's a little residential and an office tower across from the Wawanesa Tower that we built with True North that had major losses in terms of water leaks that brought up this conversation to the forefront. And I think this is when we started realizing, because this was early on in our planned IoT deployment, that this could potentially expand further. And hence why we started bringing in this idea of a full mitigation system. Overall, just to give you a highlight of where we ended up in terms of the project, so we had more than 195 IoT sensors deployment. That includes the leak detection and temperature humidity control. 18 gateways across the floor space, so 23 stories, 18 gateways. And then we had 24 months of coverage. That was kind of, call it construction, a little bit post-construction as well. And as you can see on the left side, they're inactive sensors. They no longer, of course, active on the project. Those are the temporary sensors, but you can see the temperature humidity ones, the leak detection ones, and again, I apologize, they're inactive at this point. I wish I had a picture when they're activated. But really, the permanent water mitigation system, as I introduced kind of the next part of the topic, we understood that there could be real impact because of the experience that we had with True North and ourselves as PCL. But we had to understand that this was new to everybody on the project side. So project, Eddy Solutions, myself included as part of that tech lead, and the client. So there was a huge learning curve, and you're going to see this in kind of our conversation moving forward. So I'll turn it to Adam to start getting into that detailed water mitigation system learning.
When it comes to water leaks, early detection is critical. Within seconds of detecting an anomaly, Eddy sends out email, SMS, and dashboard alerts. But we don't stop there. A trained 24/7 monitoring center is at the core of what we do to support our clients. When an alert is triggered, we follow up immediately.
Hello, speaking.
Hello, this is Rachel from Eddy Solutions. We received an alert from a water sensor located in the mechanical room on the 22nd floor behind the air unit.
Okay, yeah, I'm just running up the stairs right now. I saw the email come through. Hi, it's calling from. I'm up here on 23. Is there any way that you can shut the water off? Yeah, or 22, I mean.
Okay, sure. I can shut off the water for you. Do you know what caused the leak?
It's coming out of the backwash station.
The pressure is slowly decreasing now.
Okay. We've got less pressure now. We still have flow, it's just less now. Oh, the water stopped?
Okay, perfect.
Hang on 1 second. Yeah, the water stopped. Perfect, thank you.
At Eddy Solutions, we go beyond technology. With 24/7 monitoring and real-time assistance, we ensure that alerts don't turn into costly disasters.
I'll speak to some of our processes. It's not really going to get much into the product here today. So if anyone has any questions specifically later, I'm happy to answer. Where we really start here, and a line that's used a lot in our office for obvious reasons, is water is the new fire. So for any of the insurance folks, I'm sure maybe you've heard that before. Sometimes I feel like we're the smoke detector in the 60s. There's not a lot of regulation on leak detection technology in a commercial building, but we're starting to see change, and there are a lot of benefits coming from the insurance industry, mainly because it's a huge impact for them. It's a huge challenge for them. So we have a couple brief stats here to help you understand the impact that water causes in construction projects in particular. So about 30% of construction insurance claims are water incidents. That drives about $16 billion a year, and it makes it the number one non-weather related cause of loss. According to the IBC, water is the most common cause of property damage in the country, accounting for nearly 60% of all claims. And then as it relates more to the construction industry, obviously, as I'm sure you guys are aware, costs have surged, in this case from, one of our stats here, about 60% since 2019. But ultimately, that really means that every leak, every delay, every rework event carries an exponentially higher financial impact. And it also suggested that rework can consume 5 to 10% of total project budgets. It's really going to start eating away at those tight margins. So looking at high level, and we'll break down these 5 steps in detail, but just an overview on our process with our clients and the process that we carried out through this particular project and the importance of collaboration with everyone. Again, it's something I say often. I mean, let's be honest, water sensors and actuated valves and meters, it's not really rocket science. I think a lot of the importance and focus needs to be on how to actually implement this to, of course, have a successful deployment. So discovery is really critical for us. And again, at a high level, it's about sitting down with the end user or client and just understanding what are the objectives. Then translating those objectives on paper, so what we would call like the design phase. Again, the importance there is integrating it into the design and the drawing so it just flows seamlessly like every other requirement on the job. Coordination, so we do a lot of support on working with the engineers, but with the trades, plumbing contractor, electrical contractor, the GCs, just helping to move things along. Again, we'll get into detail. Implementation for us means setting up all of the automations, discussing and defining the SOPs, like all the procedures that people are going to follow when alerts come up. What do you do? And then lastly, onboarding. Every system you're going to deploy, as well as someone thinks they know, how this technology is going to work. You have a lot of people involved, so there needs to be this training element. So just diving into specifics, again, step 1 would be discovery. In this case here, so Eddy will work very closely with PCL's team, and there's really 3 things that we're trying to determine. So initially, of course, it's, what is the goal? What are we trying to accomplish here? Obviously, it's risk mitigation, but, how much risk are you willing to accept? Once we understand the job site goals, we'll start to take that information and create a system design with a certain intent or certain features. And then lastly, of course, in the back of everyone's mind, we need to balance all of that with budget. What do you want to spend to deal with this particular issue? So even before PCL and Eddy would sit down, what naturally will happen is PCL needs to determine, are we buying this solution specifically for this project, specifically for us, PCL, or is this something the client's interested in? And I know John alluded to the fact that they were, and we'll get into detail kind of when that happened, but it ends up being pretty obvious. Once they see the technology in action, they take it up. But one of the first things that we did, again, was sit with the team. We review building blueprints. We want to start to understand, which mechanical systems do we want to consider here, and at what level of detail do you want control and insight, which will lead into the next item. What we're always conscious of doing from a design perspective is not changing the way people do business. We don't want to change the design. So we're really looking as far as inline products. So again, we have inline actuated valves that you can turn water on and off, smart meters that are reading flow to determine if this is regular or irregular flow. Those are inline products, and so all we need to do is look at the existing engineer plan. Where are manual valves? You could shut the building, parts of the building, certain systems, and just swapping those out for electric valves. And then where do you have meters, or where would metering make sense alongside that? And at what granularity? So, we've done projects with 30 stories, and all we're doing is controlling the main incoming water. In this case, we had a lot more of a comprehensive plan that we'll look at in a moment. And then once we understand what level of control do they want as far as shutoffs, how many data points would they want to see, and data points, a fancy word I guess for sensors, the water detection sensors. Those are wireless, they got like a 7-year battery life, so it's focusing on, do we want to place them through the core element of this building, or do we want to spread out more horizontally to other fixtures, equipment, etc. Going to step 2, again, once we've defined what's the intent, how much do you want to spend, now we got to translate this to a building plan. So Eddy and PCL collaborated to translate the project requirements into a detailed leak detection design. We aligned on the equipment placements. A lot of times we do like a first pass and recommendations, you back and forth until you narrow it down to a defined scope of work. But that sets the foundation, getting it all on paper, as John said, for smooth installation and reliable protection. Again, some of the tasks, so it's creating the markups against the building blueprints, assembling the submittal package, which is essentially the markups and spec sheets, excuse me, establishing business rules and automation. When things trigger, what are they going to shut off at what time, what are the thresholds for meters, etc., which again we'll look at in more detail. And then very critically, PCL being part of all of this to circulate that information to all other stakeholders. So like if we shut system X, mechanical contractor needs to understand that, what is it going to affect, potentially damage a chiller, and so collaboration here is very critical.
Yeah, just to quickly add, a mechanical electrical coordinator or manager, maybe from a GC perspective, is very I would say they sometimes lead that effort with a project manager or superintendent. In some cases that might not be the case, that you have someone very specialized, so you need to involve a little bit more of your team members and your design, and maybe even your design consultants, to ensure there's alignment in terms of what was the intent of the design as well originally, compared to what you were not maybe adding some extra things, or as part of the design we're adding a different type of system or an automated system. So it's critical that you get a bit of that specialty or technical specialty as part of that conversation.
Yeah, so that segues us into step 3. So now that we've got everything defined, it's on paper, obviously the installation and execution starts. So one of the things that we do as well at Eddy is we dedicate a project manager for every single job, whether it's 1 sensor or 1,000 sensors. And they're supported by our project department. They manage just key tasks to basically help move the ball along, make sure stuff's being installed at the right time. So again, we are part of on-site meetings and trade coordinations. We provide enablement sessions, basically meeting with the plumbers and the electricians, and in this case PCL, to describe to them, we have this app, you're going to scan QR codes, and this is how you add equipment, because it progressively gets installed into the building as certain finishes are completed. So we supported some component of the installation as far as like the Eddy device installation, but PCL took a big chunk upon themselves to implement the technology. There's back-end setup, of course. We set up what we call campaigns, like digital placeholders, that all of the sensors and equipment gets uploaded into. Again, as I mentioned, we provide some on-site resources to support usually sensor placement, setting up maybe some of the gateways and network infrastructure, and again, meeting with trades constantly. But PCL plays a really critical role here, or any GC in these scenarios, to really manage the schedule, build us into those schedules, receive all of the products and make sure it's staged and ready for the deployment at the right times. And again, just like making sure the trades are doing what they need to do at the right time. I feel like a lot of times they'll see something they're not used to on their drawings and they kind of tend to ignore it. So PCL played a really critical role, as they usually do, in just making sure that this wasn't forgotten. Last part on the coordination, just to get into a little more detail on this project. So again, it's relatively high level, but we applied a meter and an actuated valve on the main incoming water line for the entire premise. And the main intent of that was to monitor irregular flow after hours. It's a very predictable environment. Obviously there's construction from say 6 to 5. Outside of those hours there really should be no flow. and therefore we can alert, shut down, and carry out all the automations. We took a similar logic, but they wanted more granular visibility and control over the building. So we took the same logic to what they call pressure zones. Those are about every 5 or 6 floors. And we had a meter valve on the hot and a meter valve on the cold, times I think it was 4 or 5 zones. Similar logic, but a different system. So for the heating and cooling, again, kind of high level, in a normally operating heating and cooling system, you're gonna have the same water just cycling through the entire building. There's usually a water line that's hard piped into it to refill it. They call it like a makeup water line. The idea there is in a normally operating system, you're not losing water, therefore there's no water flowing through the meter, no smoke, no fire. But if the meter does register suddenly a lot of flow entering that system, it's indicative of a leak. At least we can turn it off at its source so there's no fresh new water entering the system that potentially has a leak. Sensor wise, we attacked common and mechanical areas, so think of rooftop mechanical rooms, but also, as John mentioned at the top of the conversation here, electrical rooms, hydro rooms, elevator shafts, anywhere where the site team deems high risk. And again, during that discovery design phase is where those things are defined. And then lastly, a mix of meters, valves, and sensors focused on the temporary bathrooms, which to give you a sense, they had a bathroom set up, I think it was every 3rd floor or so going up the building. That was there for maybe 6 or 7 months and then torn down along with our equipment. But then we shifted that technology over to the permanent bathrooms. And I think that's where the main conversation started between Eddy PCL and the client. Last part here, I know this is obviously a hard to see kind of detail, but you kind of get a sense this is an elevated schematic of the domestic system. And so the building was broken down into, again, about 5 or 6 stories. We just look at the drawing, we see where we can place smart meters, valves, gateway infrastructure sensors, review that with the client, with PCL in this case, and put those on paper. So we had control over, again, certain sections of the building, which we'll see how it plays.
Then to take it into step 4, or what we call the rotation phase, this is where now you've installed your equipment. Deployment entails, in this case, after the installation of equipment, it's system notification. So this is when you start talking, and really, the highlight here is where the collaboration really comes into place, because it was such a new deployment, such a new technology for us. What it meant to have notifications that were going in text messages or emails, right? So there's annoyances too as well with that. So what does that mean for the people on site and who's subscribing to that? Meaning, is it superintendent, is it bar coordinator? In some cases, you might actually have your security guards that are doing overnight shift work in terms of security. It could be another partner, maybe it's even a client getting these alerts. So that's really critical for in the stage. System automations, as Adam mentioned, understanding when those automated valve connection points are going to shut off at what point, so the threshold. In this case, we had, let's say you're going to have a sensor, and it goes into this in the next slide as well. Does a sensor, when the lead goes off at a certain location in the building, does it actually automate a shut-off valve at a zone level, or maybe even the main? So having that understanding and education was really critical. I think that's probably the biggest learning curve, right? Because it's not something we're used to it when something automatically shuts off the water, right? So having that communication between us as PCL and the site staff, a little bit with the client and Eddy was really critical. Understanding the call list. So there was what we call an escalation list, as mentioned there, of if there's a leak overnight, who do we call first, right? Who's going to get the 2 a.m. call, which is always a problem. So who's going to get the call? What are they going to do with that call, right? So you get a call, now what, right? Are you actually running to site, like physically, or are you calling a plumber? So every building is always unique, and every construction project is unique. In this case, we had twofold. We had a superintendent that was close by the site, so they would actually be going there to do something, and in that case, if they needed to physically. Or a lot of times in the case of Wawanesa, they did actually institute the automation part and had automatic shut off instead of doing it through the application or through the call center. So these are kind of the tasks that we went through to ensure that This part of the implementation is done, and to have that final quality control and quality assurance. The last part of that, as you can see there, monitoring for the need for the new implementation for the 90 days to dial in thresholds during onboarding phase. What this means is really between us and Eddy, we're talking throughout that 90 days to understand where the nuances of there'll be things that we need to change. So sometimes we didn't want automation for certain periods. So we want to actually have that physical application on the app, on the mobile app, to hit that button to close the shut off. And you'll see this in the testimonial. Or we wanted to change it back to automation, depending on which phase of the project we're in. Are we adding more sensors, right? Are we taking away certain sensors in certain areas and placing them somewhere because we see other risks on the project. So this is a critical phase of the implementation, something to be really aware of when you're doing this. And as I mentioned, so in this automation really breaks down into twofold: flow-based automation, which Adam touched point on, and sensor-based automation. And as he spoke, we had automation running to the main incoming zones, heating and cooling. So what that means is in off hours, there could be automation if an alert comes into play with a sensor, and then the valve is shut off. That included in the zone's heating and cooling system. And then the final part of that, from a flow-based perspective, not a sensor-based perspective, is irregular flows, as I mentioned. You could have during hours, right? You could have those alerts come to your phone text message directly, instantly, and then you're actually taking action pretty much within minutes or even seconds in certain cases. Then you have the sensor base, and that's purely just sensor based, has nothing to do with kind of that water flow. You might just get a leak somewhere. It could be even, as you can imagine, 10 bathrooms is a big deal, right? Someone clog a toilet that happens in construction. So you get a clogged toilet, you get a leak. Guess what? You've got a sensor. At least it's doing something rather than not knowing. And for a couple hours, and now you've got a whole water leak on the floor, and it's going down 3 floors or 4 floors.
Yeah, I would just add here too. It's very normal that we see automation and the placement of equipment evolve alongside the construction. And a lot of times, 6 months before, there's property management that gets introduced or facility management. So a lot of these rules need to change and evolve alongside the construction process.
And the really highlight is aside from collaboration, is the customization towards that unique set of circumstances and the original intent that they designed to the project. So as we were learning, we were changing because the system allows you to customize, and you want that in every project, right? Because every project is different, as we said. Then finally into step 5, onboarding, as also Adam mentioned. So this PCL team and Eddy really getting into the training sessions, onboarding period. I was, earlier today in the sessions here at the Public Transformation Summit, we were talking education, right? This is really the education portion, right? Really educating our people to really understand those items and what it means to put a system that's automated. So critical items like review flow and consumption data into enhanced thresholds. I remember the story where we put a kind of a minimal threshold on a temporary water line early in a project, and then we had the masonry contractor start. They were using a lot of water, and that they were getting that alerts constantly because they were using much more water than we originally looked at when the project started. So you have to adjust based on also the circumstances of the project. You might not just because you put a threshold for a flow that is low, that will change over time. Ensuring users are not being fatigued by alerts, that was a big one too for project sites. So people do get annoyed by text, a lot of text and a lot of emails. So you have to also converse and make sure they understand. I'm a proponent of it's better to get it than not to get it. Like it's better to get the alert and the email not to get it. So is it a matter of just a function of you maybe having several people getting the alerts, so not one person getting it? Things of that sort is really critical. And then the most, I would say the most important, and I mentioned this at the beginning, the network infrastructure and connectivity is what drives this system. So power receptacles early on temporary side. If you do not have a robust system, and when we say robust, in this case, tamper-proof, in your temporary receptacle system or your temporary power system, you will get a lot of people unplugging those network hubs. So I know now we put a couple of covers with locks on our receptacles to ensure that nobody unplugs it and then uses it for a microwave or to power their tools. So because they don't know. Or in other cases, what we're doing more now is signage. So just making sure that the workers are aware and that people around us are aware of what is that system that's online, and please don't plug it, don't unplug it. Network infrastructure is critical, and that power solution is really important, and hence why the pre-planning is really critical. If you do not pre-plan and plan this well in your temporary design intent and your permanent, you are going to lose out on the functionality of the system. Without the network, without having these hubs, the sensors are useless, the valves are useless, they're just sitting there doing nothing. So again, having that perspective really on and ensuring the entire team understands that sequence of operation and getting those things online in proper timing, end-to-end per pool, for example, then if you don't have that, you'll lose out on actual ROI.
Yeah, I would say every time we start up a new project and we do our kickoff call, one of the lines I use a lot is that collaboration between you guys, be it the client and us, is going to be really critical here for this to work. Because again, if we're just fatiguing everyone with alerts and sensors and not paying attention to the frequency of those alerts, they start ignoring it, they're not happy, our thing's not working, it all just falls apart very quickly. So important to be cognizant of that.
And instead of taking it from me, we love this testimonial from the superintendent Curtis on the project. After deployment and planning it properly, he spoke kind of loud and clear on the real impact that he personally has had, both on his experience at the project and past experience as well. So I think it speaks volumes, aside from you and Adam kind of talking through it.
The same client, True North Real Estate Development, we had done 2 towers with them previously, right across the street. This is kind of the 3rd tower in their complex. So one of the towers that we did is a multi-residential tower, and we had been chasing leaks and fighting leaks for the past 3 years. Insurance claims, all that. We didn't know where it was coming from. We had no ability to isolate things. We didn't know about the leaks until it was too late and it had leaked through the wall or the ceiling or wherever the leaks were. We had sensors all over the place for temp washrooms, for high sensitivity areas like electrical rooms, mechanical rooms, boiler rooms. We worked it out pretty seamlessly. It's a low maintenance product. It's really easy to install. One instance, in the middle of winter, we were in the finishing stages of our program. We were at the very top floor. So it's sort of the executive floor where all the important people hang their hats. And at about midnight or shortly after, a really like an 8-inch main domestic water service line had sprung a leak in one of the flanged fittings, and it would have been catastrophic. It sent us an alert right away that there was an unusually large amount of water volume being evacuated from this one area. And so I literally picked up my phone and I hit close on the valve, and within 6 seconds it's closed. And I was 100 miles away. They're very client focused for sure. Their team, if we asked them to be on a plane and be here on Monday, and we asked them that on a Friday, they'd be here on Monday, helping us through it. Every project I'm involved with where my voice will carry enough weight to use it, I will be using it. Yeah.
So yeah, I won't describe it. You can see the impact and the change management over the time of that period, and how it changed Curtis's perspectives. We're now much closer friends than when the technology works, right? So we're going to tie this presentation finally here to the ROI. I think this speaks much more in terms of the real impact from a financial perspective and a savings perspective. So we'll finish off our presentation on that.
Thank you. So when we think about ROI at Eddy, obviously it's not really based on timeline. This isn't like a more efficient mode or anything. We think about it as a risk-adjusted ROI, meaning ultimately there needs to be an investment, and then what would be that value multiple. In this case here, there was about $65,000 of equipment that included actuated valves and meters, controllers, network gateways, and all the peripherals. And the 24-month monitoring and data costs. From PCL's input, there was about $70,000 in MEP trade costs, obviously plumbing and electrical requirements. As far as water damage prevented, there's 2 main occurrences. So going back to the first video and the first call that we were listening into, and then Curtis's explanation of that 8-inch main. And then there was a lot of other little alerts here and there that you try to quantify. It's hard to quantify something that didn't happen, but similar to the insurance world. So we estimated about $1 million plus in water damage prevented, which is a 7x return. And so again, ROI for us isn't really tied to timeline, it's tied to exposure. And the moment a major event occurs, basically everything after that is cherry on top.
The overnight leak that you heard of, I won't go into other details on that, but basically I just wanted to highlight the potential claim size that would have had to have been claimed if we had the full water loss without the sensor being in place and shutting off the water. So we were looking at around over $750,000 just for that overnight incident alone. And we did the estimate based on fire rated walls, flooring that was installed, all these little details with our estimator at the time. So again, you can start getting a perspective, the cost of the equipment versus the cost of the signal.
Yeah, and then briefly here, this was that first phone call you heard, so long story short, it was about 2 or 3 months after construction was completed. And PCL does that a lot, where they'll bake in usually 6 to 12 months of monitoring post completion, just to have that extra added coverage. It also allows us to have conversations with the facility management or landlord. But that was basically a fixture leaking in a mechanical room. The operator in this case got the text and email, but you can kind of hear, if you recall the initial video, what really caused her to take action and go and investigate was our phone call. And I always say to our clients, our call center plays a really critical role. No one really cares for more dashboards and more alerts. Like, just call me if there's a problem and we'll go and deal with it. And so again, this was in a mechanical room, so it's floor drains and concrete finishes, but estimated $100,000. If it happened Friday at 2 a.m. and went on all weekend.
So just do you want to touch base on the part or what?
Just to touch, I think we've talked about it a couple of times, and to put just a finer point on it. So again, this was procured by PCL for construction. We intended only to have it there for roughly 24 months. And the facility management company, which is one of the, I'll say, top 3 in Canada, understood that this system was installed. Long story short, toward the end of that contract with PCL, they took over the system as is where is. We did some service work to the existing system. Obviously, construction is a chaotic environment, but they've since doubled the amount of sensors or endpoints and are continuing to just establish more control over the building, which is really very typical for us to see.
That's a happy point. So to conclude, the reason we believe that this story really has an impact from an ROI perspective is it just really proves the impact of an effective and intentional planning for an IT deployment, having a plan around that. So that intent, that original intent and pre-planning, focusing on risk mitigation, so understanding your risks on a specific project that's unique, right? And have a proper technology partner like Eddy and others in the industry who work hand in hand and not just kind of leave you to the side, which then creates that success and then creates this change management that you saw in our superintendents, who are going to speak much louder into other projects or with other projects, as Curtis said, and they're going to use it no matter what. So I think I would leave you with this last kind of impactful ROI that we saw also as well as the temp humidity sensors. When we deployed the temp humidity sensors halfway through the project, we actually got rid of the overnight shift security guard for 12 months, and we saved over $120,000 in that security guard monitoring the site, because they don't go everywhere, but IoT sensors can be placed in a lot of places. So thank you for your attention, and I hope this was informative. And we'll go. We have very, very little time for questions, but thank you. Maybe 1 or 2.
It's a half-hour breakout here.
Oh, okay. Go. There's a question in the back.
We need
a mic or?
Very Pablo. Very familiar with IoT and sensors and great presentation. One of the challenges that we found is trying to mitigate risk with the sprinkler and the emergency services lines. So what is your strategies when it comes to mitigating that risk?
Yeah, we probably both speak to it. I mean, our very consistent recommendation in the construction environment is to install a meter. We often tell our clients we can't valve it, obvious reasons, regulations, etc. but you're not connected to the monitoring station yet. So at least knowing if there's any flow at any time, there's something going on, whether it's real or not, has been our recommendation for now. And you could take that further, right? You could do it at the main, but then every floor, because they got the takeoffs. Metering is essentially all we've done today.
The other potential solution that we're exploring is a bypass. So a bypass around the fire main itself, and then we cap it. It depends on the inspector, and that could change here or there, but it's something that we are exploring. I think the technology, though, from a meter perspective, where we need not talk about this, it's the meter's there, it's not ours, it's the city's, let's say, and we kind of put something on it to gain that access to the data. Some jurisdictions allow you, some don't, and so, but we're thinking that technology will advance eventually to a point where you almost like put something on the pipe and we'll just kind of give you full data. Anyways, so that's how we do it. But yeah, right now we're in those two-phase approach, and we're trying it, and we need to try it because I think you're right. We've had risk. I know we've had claims on fire suppression systems heavily on the insurance side. So
broken sprinkler head makes up a huge component of that for sure.
We had a project, not the new project, where the fire sprinkler was done. And we started putting water in the system, and there was a little piece missing up in the ceiling. And you can imagine the water we turned on the system that went down a couple floors. And yeah, you know, it would have been nice to have a sensor, because by the time the guys went out there and got a recovery, and figuring out where to shut it off is a different issue. Well, hence why these kind of systems are real critical, because most of the cases, nobody knows where to shut the water off. You call the mechanical plumber, nobody knows where his water shut off is. And so.
Yeah, and by the way, you might have heard this a few times, like at least how I refer to it as a water mitigation plan, because it's not only us, they need to consider a lot of other things. I've seen signage and training sessions and all that kind of stuff, so every time, you know, I get to see them put that plan together, we're a major component, but not the only component.
Any other questions?
Yeah, so one was so right now you guys like retrofitting for existing buildings?
Yep.
And the other thing was, before you got to your ROI slide, I was gonna say, like, at what point does it make sense? Like, obviously I'm thinking in a residential space right now, but single family homes, it doesn't make sense because you're mitigating risk in insurance claim on an asset that's not as expensive to replace than say.
Yeah,
so like at what scale are you?
We started life, like Eddy started its life in the single family home market, particularly in California. They were playing in parallel with this insurance kind of angle. You know, you put in a security camera, you get 5% off. So this was like put in an Eddy IQ in this case and get X% off, and they did great, and they proliferated through California, and then it came into Toronto. As a business, it wasn't ideal for us to manage individual homes and many of them. So that's why we really shifted all focus to particularly multifamily residential. If I had to guess, it's maybe 80% high-rise multifamily and 20%, you know, all this commercial stuff. I think it was a two-part question.
No, you kind of got
retrofit. Yeah. That's what I was gonna say. Just the only limitation in retrofit is how many inline products can you install? Valves and meters, sensors and network equipment, super easy to deploy.
And if it's the old pipes too, right? So you're looking at much more infrastructure work if you're going to start doing that kind of retrofit. You have to really client understand. Like we were just doing that kind of work in for a hotel, and it's you know, you're talking about replacing full pipes in both our plants, shutting down complete areas and rooms completely, right? So there's an impact there. On the residential side, I personally, it's not, and I'm not getting any, by the way, it's not because I know, because I'm not in the market, so I'm getting another product. I'm doing it for two reasons. The consumption data is really interesting to me, and I think it's really great when you're paying for water, right? So that's one. And second, I've heard, for some reason in the last month, I've heard several colleagues at PCL like have all these water issues at their homes, and I'm like, okay, I don't know if I want to do this. Like, so something back in the toilet, and then back in the fridge, and I'm just like, you know what? If you're going away for a week, having a peace of mind is much more important. And I think I got that from my experience doing it in the commercial side. The Curtis of the world having peace of mind as a superintendent, the same thing I would like in my home. So I would say putting a meter, so a person won't be putting a meter in the incoming, and then a few sensors. And there is insurance discounts. To what extent it depends on insurance.
There's like an infinite amount of brands that I would go low and flow, and they're approved on all these insurance programs.
Is it a subscription?
No, that's why it's ideal too. And they may have something on the app, but generally no. Like you're not gonna need to subscribe to anything for it to do this.
Any other questions, comments, or perspectives?
Yeah, John, are you baking in this in your estimation, and what phase are you greenlighting a solution like this?
Yeah, so after, and there's other PCLs in the room, so we're not there yet across the board. I think we're getting there. There's a few mandates in the company that are pushing that perspective, so ensuring that it's in the estimate. After the Wawanesa Tower specifically and a few more projects, we started baking this in. I would even call it not even almost like intent of design, like intent of even the building going up. Like so, a client approaching several contractors, and we're already putting it in at that phase. We're seeing it more still later down in the pre-construction phase where we're just finalizing GMPs, and then that's when we hit a number and inform the client that there's a number there for it. The other part of this too, the RFPs today are coming out with this anyways. So there are RFPs out there talking about water mitigation, water IoT-based systems, insurance, horses pushing it in different ways. They want to see a plan though. It's not just an IoT-based system, they want to see something more than that. But that's what we are also looking, when we see the RFPs, we're actually starting to price it in at a basic level. And what we've done in the company, and by sharing this, is standardize the approaches. So if there's an RFP call, you get a number, like a specific budget number that encompasses the minimal deployment. If you want to do the Wawanesa Tower, that's a client conversation that might be bigger, and then that's where we're at the GMP level having an actual back and forth conversation. I don't know if that answers. Yeah. But it's not across the board just yet.
It's good to hear that it's starting though.
Yeah, it is. It is. Yeah. Haley, what?
I should know this maybe or not.
No.
Relate the cost. So at the beginning, does PCL say no 100% of that cost, or do you split it out and they can't really use
I've seen a few versions of it. I'll say to date it's been PCL like headquarters procuring all the equipment, and then I think you guys have like an internal way of passing it off to districts and that. We actually though were in a recent conversation where, for whatever reason, I'll say politically, I guess, they had to put it onto the mechanical contractor, which is normal too. I'll say it a different way, like a lot of times the developer that we work with, I'll leave them unnamed, will say, you know, I understand your product, this is the defined scope of work for every building we put up. Obviously the quantities will change, but hey, you know, whatever mechanical, you need to buy all the equipment. So we can chop it up all kinds of different ways.
So PCL takes on the project level, takes on the cost of the capital cost, the equipment side, and service monitoring for that, just that short duration period. So let's say it's 24 months total, so that's all PCL costed. However, in most cases though, we are pushing that into the general expense side. So it goes back to the client. So I would say, I don't know if that answers, but like I think it's yes, it is to PCL. However, it's most of the time now it's being pushed to the client. If we want to do something on the temporary side, I'm noticing more the project team put us in a budget item, whether it gets approved or not, they're going to do it because they have some risk. But that's a smaller deployment. So maybe the short answer is yes to the client, because it goes back into the overall budget anyways. Any other questions, comments? Oh.
One more. Have you ever had something not work? Like had it installed and then it didn't work?
I mean, I'd be lying if I didn't say yes. They're honestly very rare. What I actually find more frequent is they didn't buy enough stuff and the expectations weren't really aligned. I'm not saying PCL specific. That's why I find it's really, really critical for Eddy at the beginning, at the top of these conversations.
Right.
A lot of times we come forward with our recommendation. When they start to pull certain line items out, I just want to make a point that like it was put on the table. If you remove this, assembly of 1,000 sensors focused on this system, don't expect X, Y, and Z.
Right.
Because a lot of times they try and value engineer stuff, they'll say $100,000 and they'll make it 50, and there's a lot of back and forth, but setting expectations is important.
Yes, project managers are, keen on their budgets, so you get into that conversation. At the beginning though, when we started this with as a partnership with Eddy, but even beforehand, yes, I would say we did have a few, several actually, IT sensors not catching water, and that was, I think, a conversation on what the tech looks like at the time and the maturity of the tech. However, the technology, especially in IT space, has matured heavily. So I would say we're back to this, where we're actually making an argument that you should have more than less. So at the beginning, yes, and I think now we've transitioned away from that now.
You could also have stuff, we're also now just thinking that comes up frequently, well less now, but when things are offline and no one's done anything about it. A breaker popped or a sensor was just taken away and thrown out, and the system will tell you certain things like when it's offline or hasn't reported and all that. But if no one's taking action, then it's an issue.
Brandon's standing up, so I think we're good. No, it's good. We were waiting for that.